This lecture explains how to create binary tree. We have already seen the definition of tree. A tree consists of a root node and is made up of disjoint subset, each of being a tree. For example, if you consider this tree with root 66, this is made up of two subtrees. Consider this is again made up of two subtrees, one on the left and one on the right. All these are again trees. If you consider this, you have a left subtree and a right subtree. So, construction of a binary tree is based on this principle. We will be using a recursive procedure to construct a binary tree. This is a program to create a binary tree. Like what we done before, we will be defining the link to the node as link, and we will be creating a node which consists of data and link to the left child and link to the right child. This is defined as a structure. Then we have function for creation of binary tree that is defined here. So I have already told you that we will be using a recursive function, and in the first module we studied that in the case of recursive function we will be having a base case and a recursive case. The base case is when we don't have any node. In that case we will be entering -1, and if entered data is -1 we will be returning null. Otherwise we will be filling the left child or right child. So for the left child we will be again calling the create function and returning and attaching it to the left of P, and for the right child we will be again calling the create function and attaching to P dot right. If you don't have any left or right child, we will be entering a -1. So this is the main part of the recursive function. If no left or right child, we will be returning null. If we have a left child, we will be attaching to P dot left. If we have a right child, we will be attaching to P dot right. Next we will see how to construct a tree like this. So we will be entering the root node, which is 66. Then left child of 66 is 54. Left child of 54 is 52. Left child of 52, no left child, so entering -1. Right child of 52, no right child, entering -1. Then we will be asked to enter right child of 54, that is 59. Left child of 59, 58. Left child of 58, -1. Right child of 58, -1. Right child of 59, 60, -1, -1. Then we will be asked about right child of 66, that is 75. Left child of 75, -1. Then the last entry, right child of 75, that is again -1. So this is how you construct a tree, binary tree.